In this lesson, you'll be learning about how to simplify radicals, which are square roots. So make sure you get your heading on your paper. Please pause the video at any time if you need to practice. When we're talking about radicals, we're talking about square roots. So we're just going to practice some using our calculator if we need to. So can you write example A, simplify each. And we're going to start with some common ones that we have done before. So for example 1, can you write the square root of 100? So to do a square root, you're saying to yourself, what times itself gives you 100? That would be 10 times 10. So the answer is 10. You can grab your calculator and have your calculator do it. You can go to this little x squared button, which is right here. If you see above it, there's a blue square root sign. So you hit the blue button first, the second button, and that x squared sign. And then you can type in 100. And you get your answer of 10. The next one, square root of 36. So we're saying to ourselves, what times itself gives you 36? Well, that would be 6 times 6. So the answer is 6. You can always do the square root of it, and you get the answer in your calculator. The next one, square root of 121. That's an awfully big number, so if we want to think what number times itself gives you 121, we can do the square root of it in our calculator, and we get 11, because it's 11 times 11. And then the last one, just to practice, the square root of 81. What times itself gives you 81? That would be 9 times 9. So the answer is 9. And again, you can do the square root in your calculator, the second and the x squared button. So now we're going to talk about what these numbers mean. All of these are called perfect squares. So we're going to write a quick definition. So can you write perfect squares? In order to simplify a radical, we need to know our perfect squares. So let me give you a definition. That just means numbers, you can use the number symbol, numbers whose square roots are integers. Meaning when you do the square root of a number, your answer should be a whole number, not be a decimal. So for instance, 81 is a perfect square because if you do the square root of it, you get 9, a whole number. 5 is not a perfect square because if I did the square root of that, I get a decimal. So what I want to do is I want to list my examples of perfect squares. So can you write examples? And we're going to be referring to this list quite often. So I'm just going to think of the numbers in order. So 1 times 1 is 1, so 1 is a perfect square, because if I do the square root of 1, I get 1. Well, 2 times 2 is 4, so 4 is a perfect square, because again, the square root of 4 is 2. So to get my perfect squares, I'm just multiplying the number by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. You can probably keep going on your own. I'm going to go up to 100. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. And it keeps going forever. So when we're simplifying radicals, more than likely we'll be using these numbers to help us out. I also wanted to point out that it includes exponents. So can you just write a little note for me? Also includes, that's a little s. I'll change that one s. It also includes x to the second power, or x to the fourth, or x to the sixth, and so on. Anything that has an even exponent would be a perfect square because x times x is x squared. X squared times x squared is x to the fourth. X cubed times x cubed is x to the sixth, and so on. We're going to stay away from letters for this lesson, but I just wanted to point that out. We are now going to simplify radicals, and these are the numbers that we're going to be using. So we're going to start off by doing an example. So for example B, can you write the directions of simplify each? Good enough for the directions. Simplify each. So I'll start off pretty slow, and then we'll go a little bit more, a little bit faster as we go along. So we're going to do 5 of these. So example 1 is going to be radical 8. which is also known as the square root of 8. Here's how we simplify this. In order to simplify, we have a little property that I want to put at the bottom. I'm going to put 5 examples here. I want to make sure I have enough room. So I'm going to do example 1, example 2, example 3, example 4, and then example 5. I want to put in the corner, which I could have put probably in the beginning, but I'm going to throw it down here. Can you write a little bubble? And I'm going to write property of square roots. Property of square roots. And I should have put this right before example B, but I want to make sure I throw it in there also. So here's the property we're going to be using. Whenever we have a radical, and we have 2 things underneath it that we multiply. So can you make a radical sign and put underneath it A times B? This is the property we're going to use to simplify this radical A. Whenever we have 2 things underneath the radical being multiplied, we can split it apart and give them their own radical, only if you're multiplying. So this would be the same as radical A times radical B. And you'll hear me say radical or square root, they mean the same thing. So we're going to use this property to simplify. So I'll show you what I mean when we do this first example. And it only works with multiplication. So to simplify this, I'm going to grab my calculator and see if I can even change it. Nope, it doesn't come up to a perfect square. So here's how you simplify. I'm going to find the biggest perfect square from this list that I can divide into 8. Well, 1 goes into 8, but that's not the biggest. 4 goes into 8. That's the biggest one because anything above it is higher. I am going to change this to 4 times 2. So what I'm doing is I'm finding a perfect square that goes into this number and changing it to multiplication underneath. So I have 4 times 2. Simplifying means we want the smallest underneath. So here's what we're going to do. I'm going to take this property now and I'm going to separate each of these into their own radical. So this is the same as radical 4 times radical 2. You give them their own radical. This is why I did that. We know the square root of 4 is 2. Remember, 2 times 2 gives you 4. That's why 2 is your answer. Now we just have a 2 underneath. The simplified answer to this would be a 2 on the outside with a radical 2 next to it. That's your simplified answer. You know it's simplified if there's no other perfect square that you can divide into this number. So again, to simplify a radical, you find a perfect square that you can divide into the number underneath. So let's try another one. Example 2 would be radical 20. So in order for me to simplify, I want to find the biggest perfect square from this list that goes into 20. So I'm going to show you a way to do it without thinking, without trying to divide. I'm going to grab my calculator and I'm going to go to y equals and type in 20 divided by x, like we were doing before when we found factors. I'm going to go to my table and start with 1, so move my table down. And here's all my factors. I'm going to look in my y column. Starting at the top, I want to find the biggest perfect square that is on this list. So 20 is not on the list, 10 is not on the list, 5 is not on the list, but 4 is. So 4 is the biggest perfect square that goes into 20. 4 times 5, you've got the 2 numbers next to each other. So I'm going to change this to 4 times 5 under the radical. So I found the biggest perfect square I can divide into 20. My next step says down here, I can separate these into 2 separate radicals. So I'm going to have radical 4 times radical 5. Well, I know the square root of 4 is 2. And if you ever forget, you can do, this is 1, 2, 3, 4, 5, 6, or use your calculator to find the square root. Then I'm going to go ahead and write my simplified answer. The 2 is no longer under the radical, so it goes in front. The 5 is still under the radical, so there's my answer, 2 radical 5. You always want to make sure you use numbers that are perfect squares. For instance, I'm looking at this pair. I do not want to change this to 2 times 10 because neither of those numbers are in this list. Let's try another example. Example 3, can you write radical 500? I need the biggest perfect square that goes into 500 from my list. So if I want to be lazy, I'm going to grab my calculator. go to y equals and type in 500 divided by x. I'm going to go right to the top of my table, starting with 1. I'm going to go down my list and find the biggest perfect square that's on my list. Well, 500 is not on my list. It might be, but there's no number. I can't think of a number that something times itself that goes into 500. So I'm going to keep going, and I notice that there's a 100. That's the highest number on my list. So I know that 100 is a perfect square and goes into this 5 times. So I'm going to change this to radical 100 times 5. And you can make these numbers switch. Now I'm going to separate these into 2 numbers. So I have the square root of 100 times the square root of 5. I know that 100 is the biggest because there's no other number besides 1 that goes into 5. So I found the biggest. Now I'm going to change this. The square root of 100 is 10, 10 times 10. So I'm going to cross it out and put a 10. Now I'm ready for my answer. I'm going to bring over the 10 because it's on the outside, and the 5 stays underneath, radical 5. There's my simplified answer. Here's another one. We're adding something to it. Can you write for number 4, 5 radical 27? This time I put a number on the outside. Don't get tricked by that. Ignore it for now. It has nothing to do with you simplifying the radical. So you're just going to bring the 5 over. And now you're going to find the biggest perfect square that goes into 27. And you're looking at this list right here. This is our perfect square list. So if I don't feel like thinking, I'm going to go to my calculator. I'm going to go to y equals and type in 27 divided by x. And I'll go to my table, make sure I start with 1. I'm going to look at my y column and find the biggest perfect square on my list. Well, 27 is not on my list. 13.5 definitely not, but 9 is. So that's the biggest one. So if you start from the top, you'll find the biggest. So now I'm going to change this to 9 times 3. Now what I'm going to do, just bring down the 5 for now, and I'm going to separate this into 2 radicals. So radical 9, radical 3. Simplifying again means the smallest number stays under. So now I leave the 5 alone, that's on the outside. The square root of 9 I can change to 3, so that's 3 times 3. Now my answer, because the 5 is on the outside, when it's attached, that means multiplying. So since we have 2 numbers now on the outside, we're going to multiply those. So 5 times 3 is 15. So we're going to have a 15 with a radical 3 next to it. There's your simplified answer. One more just like that. Can you write, for example, 5 for radical 50? If I'm going too quick, make sure you pause your video so that way you have time to write everything down. All right, so just like example 4, there's a 4 on the outside, so I'm just going to bring it over. Now I want to simplify 50, simplify radical 50. So I'm going to grab my calculator, I'm going to go to y equals and do 50 divided by x, and go to my table, and I look at my y column. I'm going to go down my list and find the biggest perfect square on this list. Well, 50 is not on the list, but 25 is, so that's the biggest, 25 times 2. So I'm going to change that to 25 times 2 under the radical. Now I'm ready to split it apart, so I bring the 4 over since that's on the outside, and I give each of these their own radical. So radical 25, radical 2. Now I'm going to simplify. I do not cross off this 4 and put a 2 because it's on the outside, so it doesn't change. You leave it. I changed the square root of 25, though, to 5, because 5 times 5 gives you 25. Can't do anything with the 2. Now I'm ready for my answer. The 2 outside numbers I multiply since they're attached, so 4 times 5 is 20. And I still have a radical 2, so I just bring that over. There's our simplified answer. Now, the important thing is we're going to simplify some expressions that have radicals and non-radicals in it, but this is going to help us. So I've got 4 more examples for us, just to tie in what we're doing. I'm going to switch to the next page. And I just want you to put one little note for me so that way you have this written down. And this is kind of an important note. So can you write important? Last part of the notes. When you're simplifying a radical, you cannot divide a radical by a number that's not under the radical. So can you write, you cannot, I'm going to underline cannot, you cannot divide a radical by a number, you can use the number symbol, by a number not under the radical. Not under the radical. So what I mean by that, and you don't have to write this, I just want to show you, if we had radical 2 over 2, you could not cross the 2 off and make it a 1 and this a 1. This is not correct. You would have to leave it as this because you cannot divide a radical by a non-radical, okay? Think of it as if you had radical, if you had, let's see, x over 2. A radical you can think of as a variable. You can't divide them because they're different. So I'm going to give you 4 examples where we're simplifying and we're practicing that rule. So here's example 1, just 4 of them. Can you write 6 plus radical 6? That's going to be the top of your fraction. And underneath it, can you put a 3? This question you cannot simplify because if you were going to divide, you can 6 by 3, but you cannot divide this by 3. You'd have to divide all of them by 3, so this cannot be simplified. So can you write cannot be simplified? Cannot be simplified. You can't just divide half of the fraction by something and not the other. You could separate this into 2 fractions, but we're going to leave it for now. Example 2. Can you write 6 plus 3 radical 6 over 3? Now notice I made a change. There's a number in the front. If we're going to divide, we have to divide every term by a number. So if you notice, there's a 3, a 6, and a 3 on the outside. So we can divide all of those by 3. So again, if we're simplifying, you have to divide everything by the same number. So if I divide all of these outside terms by 3, 3 divided by 3 is 1. 6 divided by 3 is 2, so that becomes a 2. 3 divided by 3 is 1. You don't divide this by 3 because this is a radical and this is not a radical. And this is attached. So now we're ready for our answer. If you notice, I have a 2 now. I have a plus sign. This is becoming 1 radical 6, but I don't need the 1 anymore, so it's just radical 6. And because there's a 1 on the bottom, we don't need that either. So there's your simplified answer. So again, if you have an expression with a radical, everything needs to be divided by the number outside for it to simplify. 2 more. Example 3. Can you write 10 plus radical 50 over 5? I'm looking at this example, I'm noticing that all 3 of these numbers I can divide by 5. The problem is this is under a radical, so I am not able to divide this. I'm not going to write cannot simplify because I actually can simplify this. So what I'm going to do right now is like we did in the beginning of the notes, I'm going to simplify this first. So think of our perfect square list that goes into 50. So I'm going to go to my calculator. I want to simplify this. We're going to see what happens. So I'm going to do 50 divided by x and go to my table. The biggest perfect square from that list that goes into 50 would be 25. So 25 and 2. So what I'm going to do is I'm going to change this to radical 25, radical 2. It's the same as 25 times 2, but notice I'm separating it now. The square root of 25 is 5. So now what I can do is I can replace this right here with this. So let me explain really quick again. I can't simplify this yet because there's no number outside this radical attached. So what I noticed is I can simplify this radical. I broke this down. It's going to become 5 radical 2. So can you rewrite this for me? We have the 10 and the plus sign. I'm changing radical 50 to 5 radical 2. And I still have the 5 underneath. Now, if you notice, every term has an outside number, and I can divide them all by 5. So now, 5 divided by 5 is 1. 10 divided by 5 is 2. 5 divided by 5 is 1. So now I'm ready for my answer. So I can bring down the 2. I have a plus sign. I'm left with 1 radical 2, but I don't need the 1, so it's just radical 2. I have a 1 in the denominator, and I don't need that, so there's my simplified answer. Last one, number 4, just a little more complicated. Can you write 6 plus radical 8 at the top? And underneath, 4. First of all, I've noticed that I can divide these two by 2, but since there's no number in the front, I cannot divide this by 2. But I noticed that just like this one, I can simplify this radical 8. So I'm going to simplify this and then see what happens. So I need to think of my perfect square list, and that was from the front of the notes. So this perfect square list, which number can I divide into 8? Well, 4. 4 times 2. So I'm going to change this radical 8 to radical 4 times radical 2. The square root of 4 is 2, so I'm going to cross this off and put a 2. Now I'm going to change my expression, and I'm going to replace this with 2 radical 2. So we have 6 plus, instead of radical 8, it's 2 radical 2. And underneath, I still have a 4. Now, if you notice, every term is an outside number, and what can we divide everything by? Well, 2. So if I divide by 2, 4 divided by 2 is 2, 6 divided by 2 is 3, and 2 divided by 2 is 1. I cannot divide this by 2 because it's under a radical. So now I'm ready for my answer. So we have 3 in the front, we have a plus sign next, 1 radical 2 is just radical 2. And because there's a 2 on the bottom, I have to keep the 2 on the bottom. I just want to point out that you can leave your answer like that, or you can always separate a fraction like this. You don't have to write this. You can separate this into 2 fractions, with them each getting a 2. So you can write 3 over 2 plus radical 2 over 2. Notice I just gave the 2 to both terms. So that's another way to write it. Please make sure you take a picture of this and submit this into Canvas.